This is a quick demo video of SimpleSim. We'll see how to download and install it as well as some of its basic functionalities. So first you'll need the SimpleSim zip file, which I have here, and this will be distributed to you. Once you have it, grab the folder inside and put this inside of your ROS workspace source directory. So I put it in here, and if you'd like, you can rename this to just SimpleSim if it's not already. You'll also, in addition to the SimpleSim base code, you'll need the simulation environments. And so right now on our homepage at github.com/LTU ROS, there are two, though there might be more by the time you watch this video. The ones we're going to download are Crosswalk and Office. So if we click on Crosswalk, we can download it using either git clone or download the zip directly. So in this case, I'll just use git clone. I'll copy the URL and we'll go to our source directory and click open in terminal. And we can run git clone and then paste that URL in. Now I already have it, so it's going to tell me that I already have it. So do the same thing for Office as well. Again, download it as a zip or clone it, but either way it should be in your source directory. So here now we have SimpleSim, SimpleSim Crosswalk, and SimpleSim Office. Once you've got everything, you can go into, I'll just do this, go into your source directory and then go back into your workspace directory and run a catkin make to build everything. And so we're going to go ahead and let everything build here. Once everything is built, we can try testing some of these. So let me open up these examples again. So in SimpleSim Office, and these may vary depending on whichever package you have, but each of them have only a launch folder like this one, and they might have one or two launch files. So in this case, SimpleSim Office has a single launch file called office.launch. So let's go ahead and launch that one. So we'll go, and remember once you build to do source devel setup.bash. Now we can ROS launch SimpleSim Office. Office.launch. So that will go ahead and pull up our Office simulation environment for SimpleSim, which we can see right here. So there are a couple windows. I'll go over them quickly. The main one is this playing field. Now this is the actual simulation that we see here. And we can see we have our robot here in green. It's got some wheels and a camera in red, and the LiDAR is this blue dot here. It has this background image, which is just a generic image. It supports arbitrary images. We see axes markers here with a Y positive and X positive arrows, as well as some physical objects, which are these gray circles and boxes that we see around here. And so we can go ahead and look, and we also have this camera view. This is what the robot can see from its camera. Which is this red thing here. So if we go ahead and open up another window, which is somewhere, here it is, this RQT robot steering. This is our control over the robot. So if we pull this forward, we'll see the robot drive forward, and if we go backward, we'll see it drive backward. And similar with this slider down here, it'll drive left and right, and we can stop it by pressing the 0 button. The other window here, this is dynamic reconfigure. This is RQT reconfigure on the top. It is dynamic reconfigure. So we've seen this before. If we click on SimpleSim node, we see that there are a couple of dynamic reconfigure options. Some of them are just visual options, and some of them are behavior options. So at the top here, we have a couple of camera options. If I enable the camera border, we can see what the camera is rendering. And we can modify the camera's height using the Z. We can also modify how far out into the distance or far down it's looking using this slider here. We can enable or disable the LiDAR using this checkbox. We can see that its detections are these blue dots here. It has some parameters for the LiDAR as well. Some of the important options that might be used more than the others are these collision types. So the simulation supports various collision types. So right now the collision type is set to none. So if I drive the robot into this circle here, it's just going to kind of pass straight through it. If I set it to a soft collision, we'll see that it will still drive right through it, but it'll notify you by turning the screen red when it's passing through an object. The last one is hard collision. which means it will actually stop the vehicle before it's able to drive through the object. There's also another option here for exterior walls, and so by default the exterior walls are treated as there's not being a wall there. So I can actually just drive the robot and it will go just off the map through the wall. We can disable that by turning on exterior walls, and we'll see the robot will actually hit the wall just like that. It'll hit the edge of the map. So let's take a look at some of the data that's actually coming out of here and how we can use it with ROS. So if we open up another terminal, and this window, by the way, will probably stay above all the other windows, so I'm going to go ahead and minimize that. So let's go ahead and we'll open up a new terminal here. There we go. And while I have the simulation running, I can do a ROS topic list, and we see a couple of topics come up. So the first are these familiar camera view topics. Now these are general camera topics, just like how we would see out of any camera, including a webcam camera or something like that. And we can actually run, just like we would run for a real camera, our RQT tool. And we have our camera views here, and I can switch it to view the robot camera just like this. And so it's treated just like any other ROS camera. We can see the camera straight in a standard RQT window. So that's very useful. There's a couple other topics that are worth noting. So this CMD_VEL, if we do a ROS topic info on CMD VEL, just like this, we'll see that this is actually a twist message. And so if we are familiar with twist messages, this is the message that we publish to the simulation in order to control the robot. So if I open up our RQT steering, we see that it's actually set to CMD_VEL as well. So this is publishing to CMD_VEL, and it's also moving the robot. So if we write a node to control the robot, we'll need to publish on this topic with a twist message. The other, another couple notable topics here, which we'll go into more detail later, but we'll talk about them briefly here, is we have this /scan, and so if we do a ROS topic info on /scan, we can see that this is a laser scan message, and this is actually our LiDAR message, so we'll talk about that later. There's one more, which is the ODOM. So if we do a ROS topic, we'll do an echo this time. We'll echo the /ODOM. And this is actually the simulation localization. And so here we can see there's a position field. And as we drive our robot around, the position field will update. So the robot is actually able to localize itself and give out an accurate position as well as an orientation, which we can see changing there as well. So these are some of the topics that the ROS topic list that the node publishes here. The final piece is, let me go ahead and close this. The final piece is the environments in general. So the environments are distributed as these ROS packages, and so we use this ROS launch SimpleSim office.launch to run the first environment, but there are many other environments that can run with SimpleSim. So the other one that we downloaded is Crosswalk. And so we can launch that one by just launching the crosswalk.launch. And so, like I mentioned before, every single one of these SimpleSim packages is going to have its own launch file. And you can just look in the launch folder to find out what launch file it is and launch it. And so in this case, it's just called crosswalk.launch. And if we launch this launch file, we'll see a similar handful of windows pop up, but we have a very different playing field window, and we're actually running a crosswalk simulation. So here we have a vehicle down here and it's driving toward a crosswalk, and it'll work the same for any type of other simulated environments that you use. Just load up the package and run its launch file, and it will run SimpleSim. And just like before with our previous example, if we do a ROS topic list, we see a lot of the same topics like we did in the last one. So that's a quick overview of SimpleSim and some of the topics that we have. And as we move forward and have more examples, we'll be using this more and exploring some more of these topics. But this is just to give you a sort of overview of what are some of the basic capabilities that SimpleSim has and how to install and use it.